Good morning, everyone. So in the last class, we discussed about address resolution protocol, ARP. So what is ARP? It is used to identify the MAC address of the devices with the help of known IP addresses. Then we discussed about the proxy ARP. So proxy ARP is what? Like whenever the devices are in the different network, so the if any devices requires any MAC address of any other devices, so in that situation, who will give the MAC address information? The router will. Okay. So that is called as a proxy ARP. And then we discussed that ARP request is in what form? Broadcast form. And ARP reply will be in what form? Unicast. And default gateway, like each router is going to have multiple interfaces, and that multiple interfaces will be acting as what? Default gateway. Correct? So first today we'll start with Telnet. So what is this Telnet? Telnet is teletype network. Teletype network. Why do we use? It is used to remotely access the device. It means here that rather than accessing directly, we will be accessing the same devices remotely. It means let's say we have a router or a switch. Let's say we have a router or we have a switch. So it is located at one location, but instead of directly connecting to that devices and accessing that, what is possible? That the user is located at some different place and he is trying to access that router or switches remotely. So how he is going to access that? With the help of this protocol that is called as a telnet. So it is used to remotely access the devices. But when you will access the devices using telnet, whatever transmission that will take place, it is going to be in the plain text or in the clear text. It means it does not provide any encryption. No encryption will be there. Whatever transmission is happening there, it will be in the clear text or plain text. Means everything will be visible, right? If you will capture the packets. So what is the port number of this telnet? Port number of telnet is 23. And what use it uses? It uses TCP, right? It means it is reliable. Right? And same as we have SSH also, that is called as a secure shell. It is also used to remotely access the devices. But what is the difference between Telnet and SSH? It provides encryption, right? How it provides encryption? Using RSA. Okay, that is reversed Samir and and this is the encryption, like whoever has developed this concept, it is their names, reversed Samuel Edelman, and most preferred way of encryption is this is only RSA. So this method will be used for encrypting this. Okay. Port number of this SSH is 22 and it uses same TCP. So compared to Telnet, SSH is what? Encrypted, more secure. That's why we can say that SSH is secure, right? So it is written here also in the PPT that Telnet is what? It stands for Teletype Network. It is used to access network devices remotely. Telnet is a network protocol used to virtually access our devices using Telnet transition of data packets into the plain text. Port number is 23 comes under TCP, whereas SSH is what? Secure cell. Here data gets encrypted. By this, we can access our network devices remotely by using encryption. And because of the security purpose only, we have moved from Telnet to SSH. Port number is 22 and it uses what? TCP. So this Telnet and SSH is which layer protocol? Application layer protocol, that is called as a layer 7 protocol. Okay. Application layer protocol and it uses what? TCP. Now we'll see how to configure this Telnet and SSH. IP address on this interface will be 192.168.1.1/24. Here we'll give it as a 192.168.1.2/24. 192.168.1.3/24. So first we will assign the IP addresses. Come to this router, CLI, if enable, config space T, give a host name, first host name. Let's say host name, we'll give it as a telnet router. Okay. Next interface number is what? G0/0. IP address is 192.168.1.1, 255.255.255.0, and give it here no shut. Not mandatory, but we can give. Okay. Then given, give exit. Now you check do show IP interface brief. We have configured the IP, correct? Now what will you do? You have to configure telnet on this router. It means that if you want that this is my device, this particular device has to be accessed remotely. For the first time, you have to configure telnet on this device. Then only you will be able to access it remotely. Okay, so for the first time, we have to configure here telnet. How will you configure? First, you will write here line VTY. What is this line VTY? Line virtual terminal. It means that how many sessions you want to enable for this particular devices. It means at one time, how many different devices can access this my router. This is called as a line VTY. What is VTY? Virtual terminal. Okay. When you will give a question mark, here it is showing you 0 to 15. It means total 16 possible sessions are there possible here in the Cisco packet tracer. When you will check in on the real devices, this value will change. Okay. So here it is showing you 0 to 15. Let's say we'll write here 0 to 1. It means total how many session I want? 3. So, sorry, 0, 1, 2, yeah, 3. Okay, sorry, 0 and 1, 2, yes, correct. 0 and 1, so 2 session I want, right? Because we are giving here, starting is 0, ending at 1, total is 2, correct? So line VTY we have given. Next is what? Next we have to give a password. Which password? Login password. So give here password. So password, let's say we will give it here admin 123. Now it will ask you for what you have given this password. So I have given it for the login purpose. So whenever anyone is trying to access this devices, he has to provide this login password first. Okay. So line VTY, password, and this login. This is only the command. Next, it will always ask you to provide enable password. If you will not give enable password, it will ask you to give enable password. on the router. Okay. So where to give now only. So what is the enable password? ABC123. Okay. Now, one more thing. Now here, if I want that only telnets would be allowed, not any other protocol like SSH. So for that, you have to give one more command, transport input telnet. And that command you will give after line VTY again, 0 to 1. Then you will give transport input telnet. With this command, what will happen? If you're giving here transport input telnet, it means telnet is only telnet will be allowed. Okay, we'll show you the importance of this command when we will configure SSH. It means what will happen now? If we have configured SSH, then also you can access that devices using telnet. Okay, but if you want that no, telnet should not be allowed, then there you will give transport input SSH. Okay, we have given this. Now you come to this end device, desktop IP configuration 192.168.1.2. See, as my router interface is in same network. So here default gateway information is not required. Okay. Default gateway information is only required when you have to go out of this network. Next, you come to this PC, give here IP 192.168.1.3. Then, now you come to this particular PC. See, I will try to access this router from this PC. Next, I will do changes on this PC for the router. And when you will check on the router, all the changes will be applicable. Okay. See, come to command prompt, give here command telnet. Now what telnet after that? You have to give the IP address where you have configured the telnet. It means IP of the router interface 192.168.1.1. So when you are giving enter, what it is asking you? User access verification. It means first is password. Which password? Login password. What we have given? Admin 123. Came to the router. Now what will you give? Enable. Again, it will ask the password. What is that? ABC123. Now let's say I will change the host name of this router from this PC and we will check whether this changes is applicable on the router or not. Host name. Tell me any host name. Let's say R1. Done. Now we have to verify whether it is applicable on the router or not. Changed. Yes. So from where you're doing these changes? From the PCs. Now let's say you want to add one banner message. Banner MOTD. So let's say we will add here. This is telnet route. Okay. This banner message I am adding on the router, but from where I'm adding? From the PC. Now you have to check on the router whether it is present or not. Give exit. Give exit. Yes, it is present. This is telnet router. Okay. Same as you can do all different other changes. Like, for example, if you want to add one more line BTY, it is also possible. Everything can be possible, but just one thing cannot be possible. You cannot change the IP address because it is already configured here, right? Correct? Same. Now we will try to see using simulation. See, give here telnet 192.168.1.1 it is now. Come to simulation mode. Now, what is the password? Add min 123. Right. And now see here, all the packets, whenever I am typing anything, the packet is going to be generated here. Now see here. What is this? Telnet layer 7 it is. What is written? Telnet data. And what is written here? A. A is written. A. Then again, if you look, open next packet, D, M, I, N, everything is what? Visible here. See the second one? What is written? D. Third one, M. Right? It means whatever is being transmitted, it is in the plain text, clear text, not encrypted. But when you will you use SSH, what will happen? It will show you SSH data encrypted. Nothing will be visible there. That's why SSH is secure. This is not secure. So first we'll write the commands that we have given. Okay, just wait. Let me write first command. Telnet commands. So what we write first? Line VTY. Then we give a range for that. Then password. And why we are giving this password? For login. And then enable password. Line VTY. Transport. Input. Tenant. The last command that we have given is not mandatory. Okay.
Sir, can we change password?
Huh. Change it, no problem. Hmm. Even you can give a execution timeout. Okay. It means what? If there is no any activity, you should be logged out from that devices. Okay. That is called as an execution timeout. Let's say this is a ranges of the seconds that we can give or time in the minutes. Okay. So execution timeout, let's say I have given 5. So it will be applicable there. So you can give this command also, execution timeout. If there is no any activity, you have to get logged out from that device. Okay. That's why. So give here one more command. Execution timeout. And whenever you have to search about the values or what should come after this, you always use this question mark. When you will give the question mark, it will show you. Okay.
Really gracious ARP not working.
Why?
When we change IP address,
See, if you will change, I'm not telling that here, if you have multiple IP addresses, same IP address if detected, then Gracious app will work. No. What is the function of that? When we have to detect multiple same devices with the same IP addresses. Or if there is any changes, then we have to update also. That is the
so if
function.
you're changing something on router, like IP address, we change on router.
So we are changing it on the router. No, who sends our Gracious R devices sends. Okay. It is showing in the minutes.
Sir, what is the command password of router?
Just to give no password, then add new password. Like you have given enable password. You give no enable password. We can give it here. But it is mandatory to give enable password. Okay, you have to add new enable password. Now, okay, he's telling to add new IP, right? Interface G0/0. Let's take one. It is 168.1.10.55. What it says? Connection refused by remote host. Correct? Because this is the IP that already has been given to that particular device. If you will change the IP, how other will be able to access that? Correct? The IP should be same, and it has been given for the first time for the route. Okay. Now next is what? Come to command prompt. Telnet 192.168.1.1. And so you one more method we have for this tenant configuration. This is one method where you have just given what line BTY and login password. No username we have given. Okay. Now I want to give username as well.
Action. Yeah.
Hmm.
Sorry, I missed out. You need to create the command and create
Not
the
audible.
timeout.
Not audible. Let's say username we will give you UPC1 and password we will give XYZ123. Then if we give line BTY 0 to 1, password is admin123 login local give exit. Now you check telnet 192.168.1.1 Which one? Pro IP interface brief. How it changed. But here it has denied, no? It written that connection refused by remote host. How can was Telnet 192.168.1.10? Yes, but it has refused that connection refused by remote host. Maybe there would be some bug in this particular Cisco packet tracer. So we'll try this on the real devices also once. Okay, whether it can be changed or not. Because here it is showing no, but it is being changed also. So what is the password we have given? Admin. Okay, sorry, username we have given. Now only we have changed the username is what? PC1. And what is the password? No, XYZ123. Okay, now see close again, section closed by war and host. Test the command. Set admin 123. Telnet 192.168.1.10 PC1. Okay, let me show you with the SSH now. But you can write here one more point for that. One more method we have. Or you will write username. Then you will give a name for that. Then password for that username. Then you just give directly login local. No need to give any password. What you will give login local, and you will give it only after line VTY. Line VTY that range. Then you will give login local here. So with this command, what will happen? Even it is going to ask you username, and you can add multiple usernames. Okay, if you, let's say you have taken 4 PCs, add 4 different usernames like that. Hmm? Then you will, if you forget the password, you have to break the password. No, how will you access them? That will come at last. We'll come to that part. This is your first class, right? How will you manage then? So Swapna, as you are telling execution timeout, so we can say that, let's say you have logged in to any other devices, right? And you are not doing anything over there. So you have to log out after certain times. That's why we are giving here execution timeout. Next, we'll take one more router. Switch and PCs. Here we'll give one IP 10.1.1.1 slash 24. This one is 10.1.1.2 slash 24. This one is 10.1.1.3 slash 24. Okay. Now come to this router. CLI, give no. Enable config space D. So again, it is not mandatory, but we can give host name. Okay. like SSH router. So what is the interface number we have? G0/root. IP address is 10.1.1.1.255.255.255.0. Give here no shut and give here exit. Now we will configure here SSH. For that, first we have to give here what? IP domain. We have to give a domain name here. If you will not give, it will ask you to give. Okay. So what is the domain name? Let's say nh.com. We have given. Okay. Why do we give this? So that we can identify that this particular device belong to this particular organization. Okay. That's right. Next, after that, you have to give here what? Username. Username is what? Any name we can give. Tell me any name. PC1. Password is what?
PC1.
PC123. Then one more username. PC2. Password is what?
PC2.
PC
P2.
213. Don't forget the password.
P2.
Okay. 456. Huh? You can keep it. Hmm. But if you're changing the devices, why to keep the same? Right. So we have given here PC123 and we have given here PC456. Okay. After this, what you have to give? See, as we are using here SSH, we have to encrypt this. Correct? So for encryption purpose, what we are going to use? RSA. So crypto key generate RSA. Crypto key generate RSA. Then when will you give the question enter? It is telling you here, see that choose the size of the key modulus in the range of 362.4096 for your encryption purpose. It means what is the range for encryption? It is telling you that you have to choose from 360 to 4096. Any value we can check. So for this SSH, the recommended value is 768. At least we have to use 768 for encryption purpose, right? Now, when you are going, why it is recommended? See, because when you will use, let's say you are using 4096, so this is very high value. So your devices will require more CPU utilization for encryption. That's why higher the value, more utilization. That's why prefer the that range or that value that has been assigned to the SSH. So for the SSH, the nominal value is 768, or in the round figure, you can go it with the 800 also. Okay. So we have given here 768 bits. It means 2 to the power 768. That many encryption variations are there. Now, once it is done, then what will you do? We have given username. We have given two usernames, crypto keygenet RSA, then line VTY 0 to 1. Okay. Next, login local. It means we are saying here that whatever the username and password I have given here, this is for login. Login from where? Local. Okay. Done. Give exit. Now you come to end devices, desktop IP configuration, 10.1.1.2, 255.255.0. Same come this one. Desktop IP configurations 10.1.1.3, 255.255.0 command prompt SSH space hyphen L. Then what will you give? Huh? Then 192.168, sorry, 10 dot no, 1.1.1. It means you are giving here SSH space hyphen L. Then you will give username who want to access this. Here only you have to give the username. Then you're giving here what? IP address. What is the password we have given? PC123. Okay. Now, if you will give here enable, what it is telling you? It means this is mandatory. Yes. No password set. You are not able to come. No. Again, you give enable. No password set. It means to come to this enable mode, you have to set the password. Correct? No. That's why we have to set enable password admin 123. Now you give enable. Asking the password admin. Correct? Now, now we want to add a new users. So let me change the line VTY now, or let me add one new username and password is okay. Line VTY login look. Okay, we have given this. Give exit. Come to this second PC. Command prompt SSH space hyphen L. Who want to access? What is IP? Got it? It means I can add one more user. I can add one more password from where we are doing this from the PC, right? And this is being applicable also. So these are the changes we can make it on the PCs and that will be visible on the routers. Now, whatever the changes we have done here, now we have to check it using the simulation mode. So let me again do it SSH-L. Come to simulation. Now give the password. Right? Now check. It is layer 7 SSH. What is it in here? Data is what? Encrypted. Same here also. What is it in? Encrypted. So it means nowhere it is visible, right? What is it in everywhere? It is going to be encrypted. It is going to be encrypted, correct? Yes. So this is the means benefit of this SSH, where whatever transmission that is happening here, it is going to be in which form? Encrypted form, secure form. So write down the commands for this. Now, one more thing, let me. So first, then we write, okay? See, now, for example, here what we did, we are using with SSH, right? Now give exit, give again exit. I'm using it with SSH. Now we'll try with Telnet. Telnet uh, 10.1.1.1. See, I have configured SSH, but with the Telnet also, it is also applicable. What is the username we have given? Let's say PC1. Password is PC123. Enable. It means I am able to access it with the help of Telnet. But the means it means what here what will happen? Everything will be fine. Just encryption will be removed. Correct? So if you want that, no, only telnet should be, only SSH should be allowed. Telnet should not be allowed. For that, you have to give again one more command on this router, line VT5 022 transport input SSH. So if you have given here SSH, then what will happen?
Yes.
Telnet will be denied. Try to access with telnet now. Give here telnet 10.1.1.1. What it says? Connection closed by foreign host. It denied that. Now write down the commands. SSH commands. IP, domain name, and domain name we have to give. Then a username we will give, that name. Then a password we will give. Same if you want to give again one more username, that is also fine. Then same again password. After that, crypto, key generate, RSA. Here you will key, here you will write what? Cube modulus range. Let's say I'm writing it 760. After that, line VTY 02. Let's say, for example, I've given 02. You can change those values. Then login local and transport input
Enable passport, right?
SSH.
Enable password.
Enable password is also required. So at
Yeah.
last, we give it enable password. Otherwise, it will ask you to give. If you will not give. Correct? Clear?
What is login local?
Login local means you are telling that if any other device is trying to log in, so locally he will log in from his own location, but that device is what? Remotely. That's why we're providing here that whoever is going to log in locally, he has to use this all credentials to log into that particular remote devices.
Just follow these commands only.
But extra commands is also there that I have not given. Okay. Like retry. Retry me is also there. No, like here, what is happening? 3 times we are giving the commands. It can be changed. It can be modified, but that is not required now. Okay. Question.
After, but can it do I?
Means like no. Okay. So for example, you have configured Telnet, then you have configured SSH, and then it is possible. Without configuring SSH, how will you access that? Means RSA has to be given. No, crypto key generate has to be given to work SSH. Okay. Without that, how it is possible? So first you need, if you want that, okay, I have configured Telnet. Now I want to configure SSH. It is fine. You can configure SSH. Then in that situation, Telnet is also there, SSH is also there. Now you want that only SSH should be allowed, Telnet should not be allowed. Then you have to give there only command transport input SSH. Okay, so that other users cannot access this using Telnet commands. Clear?
We can count out Telnet config
Hmm.
using PC can configure SSH.
Using PC. Okay, let's try then. As I told you, that to access any devices, you have to configure it on the devices. No, how you can do it from the PCs? Huh? Hmm? Why I will try? You only try. Oh, you try and then let me know. Let us know. Even try on the real devices. So one day what we will do, we'll access the real devices remotely here, so that online students can also see that. And one day we'll go to access physically, and that will not be possible for the online students. Okay.
So the only difference is encryption.
Which one? Yes, the difference is in the case of SSH encryption part. It is going to be secure. Any other questions? So this is Telnet and SSH. Now we'll start with the routing. What do you mean by the term routing? Hmm? See, routing, it is a process of finding the best path between the source and destination, right? If source and destination is located in different network. Routing, it is a process of finding the best path between the source and between the destination if your source and destination is located on a or in a different network. So once the best path is identified, that will be called as what? A route. Okay. So what is this route? The best path to reach the destination is called as route. One is routing, one is route. Routing is what? Process of finding the best path. Once the best path has been identified, then it is called as a route. Okay. So for example, let's consider here that we have certain routers. Okay, this is router. This is router 1. Next, this is router 2. This is router 3. This is router 4. And what it is? Server. Now, to access this server from the router 2, you have two options. You can go it from router 2 to router 1, then you can access it. Or you can go it from the router 2 to router 3 and router 4, then you can access the server. Now you tell me which one is the best path for you. Via router 2, router 1, and return server. It means that one process has been identified here to identify the best path. Okay. What is that process called as? How you defining it? This is the best path based on the number of hop counts. So you told that, okay, if I have to reach from R2 to this server, so if I will go from router 1, I have to cross only one router. If I will go via router 3, it means I have to cross router 3 also, router 4 also, then I have to reach server. It means here process is finding the best path. In that, how you're going to find that? Based on the number of hop counts. Here you're telling I am going to cross only one router. Here I'm crossing two router. Obviously, this is my best path based on the category or based on the criteria number of hop counts. Okay. So now once you have identified that this is my best path, this particular path will be selected and will be taken for the transmission purpose. This will be called as what? Route. Route. Okay, that's why it is written here. Route is what? Once the best path has been identified. Okay. But here, according to our discussion, we identified that this is my best path. But always this is not going to be a scenario. Means always number of hop counts will not be enough to identify the best path between the source and destination. There are different other factors also. That other factors we'll discuss when we'll start with the dynamic routing. Okay, because there will be using different protocols, and based on different protocols only we'll understand which protocol supports what type of metric cost, right? So see here it is written what is routing. So it says that routing is a fundamental process in networking that involves selecting the paths in a network along which the data packets travel from a source to a destination. So it says that it ensures that data sent from one device reaches the correct recipient even if the recipient is located in a different network. Then what is this route? Route is what? Route is the best path selected by the router to reach from source to the destination. And all the information will be stored where? In the routing table. And it is called as what? It is called as it is a collection of routes to transfer data from one domain to another domain. All the information will be coming under this routing table. And all this process is based on what? IP address. Okay. So the internet protocol specify the origin and destination. So for each data packets and routers will inspect each packet's IP headers to identify where to send them. Correct. So all this process is based on what? IP addresses. So the next slide is written about dynamic routing. So we'll not discuss now. First, we have to complete the static routing. Then we'll start with the dynamic routing. So before coming to the static routing, first we'll understand what is this loopback interfaces. See, when we were discussing about the IPv4 addresses classes, there we discussed that we are having certain loopback address. This is not loopback address, this is loopback interface. Loopback address like a virtual address. This is loopback interface like a virtual interface. See, what is the scenario? Why do we require this? Now, for example, here you have taken router, and this side also you have taken a router. Now, as you know that if we are going to connect this router directly, so this is, let's say we have router 1, and this is router 2. So don't you think that between router 1 and between router 2, we will be having one common network? Common network. Let's say, for example, here we have given 192.168.1.0 or 12.0 because it is between the 1 and 2 routers. So 12.0 we have given. On the interface of the router 1, we have given 192.168.12.1. And this side I have given 192.168.12.2. Correct? It means this interface or these are directly connected interfaces. belonging to a common network. On the router one, you want to do routing and you want to verify whether I am able to reach router 2 or not. In this case, routing is required. No, because it is directly connected network and you will be able to ping. If you want to ping from router 1 to this interface, directly you can ping. No routing is required. I want to verify the routings. What is required here? This side you have to use one more connectivity where you have to use a cable, connect to the physical interface, then connect to a PC or switch. Then you assign a IP on that particular PC. Even you assign the IP on physical interfaces, then you do the routing, then verify. Forget this. Now what happened? I don't have any cables. I don't have any other devices. Then also I want to verify it. How will I verify? Using virtual interface. Rather than assigning the IP addresses on the physical interface, I may assign it on the virtual interfaces. And that virtual interfaces is called as what? Loopback interfaces. Okay. So this side, what will you do? You will assign one IP, let's say 2.2.2.2/24. Okay. Now it is in different network. It is in different network and also between two different router. It means here default gateway is not enough. What is required here? Routing is required. Correct. So if you want to reach from router one to this network, routing is required. And where you have configured this IP on the loopback interface. And what is a loopback interfaces? Virtual interfaces. Okay. So we can write here loopback interface is a virtual interface that is used for testing and verification purpose. It means that you know that real transmission cannot take place using this loopback interfaces. No, if you want to send real data, as it is a virtual interface, how it will send real data? Okay, but this loopback interfaces has its importance in the BGP. Like when will you come to routing part, CCNP routing, not CCNA, CCNP routing. There you will know that okay, we can form the neighborship using loopback interfaces in the in the BGP. So neighborship will be formed using what? Loopback interfaces. IP configured where? On the loopback, not on the physical interfaces. What is the reason why it is formed that? We'll come to that part when we will be starting the CCNP. Okay, it means that it is not having only importance in the simple routing process or testing or verification purpose. It can also be used for what? Formation of neighborship. Neighborship formation. Okay, so see here it is written that loopback interfaces are what? Virtual interfaces used in networking. They allow you to assign IP addresses to a router which is not connected to any physical interfaces. Where we will assign the IP? On the virtual interface, because you know that we have to assign IP on the routers where? On the interfaces. It can be a physical, it can be a virtual. If you want to assign it on the physical interface, then that physical interface must have a physical connectivity. Otherwise, it will not be able to assign the IP addresses. Now, what it says that as they don't have any physical attributes which can fail, loopback interfaces never go down. So whenever you are configuring the IP addresses on the physical interface, what command you give at last? No shut. Here that no shut command is not required in the case of loopback interfaces, right? So see how to configure that. Okay. So on the router 1, how many IPs are there? 3 IP. Come to router 1. Or let's consider this is router 2 and this is router 3. Okay. Give no. Config space T. What is the host name? What is the interface? G0/0. IP address 192.168.255.255.255.0. Give here no shut. Give here exit. Now where we have to assign the IP on the interface loopback. How will you assign? See interface. Just you write L, give a question mark. These many numbers we can use for forming the loopback interfaces. Okay. So let's say we're going with the loopback interface 1. L1 loopback 1. What is IP? 1.1. IP address is 1.1.1.1. 255, 255, 255.0. Give exit. Now how will you verify? Do show IP interface brief and see here. This is the IP we have configured on the loopback. And see, I have not given any command for no shut no. Here we have not given no shut command, but that too also what happened? This is my up loopback 1. Now I have to configure where on the loopback 2. One more IP is there, no 11 dot. See this one, correct? So how will you configure this? IP, okay, interface loopback 2. IP address 11.11.11.255.255.255.0 and give exit. Then do show IP interface brief. What is IP? Configured here. So on the router 1, we have configured 3 IP. One on the physical interface G0/0, one on the loopback 1, and one on the loopback 2. Clear? Okay, for you, one task. You have to search, you have to write it down, and tomorrow you will tell me what is the meaning of this G0/0, G0/1, G0/2. It is an interface number that we know, that is fine. But there must be certain uses of this G0. Then again, we have a slash, then we have a 0. You do it. You first do it, then you tell me, okay? You search on that, note it down, then tomorrow you will let me know. Done? One more, right? G0/0/1. Because this is one router where you will find this type of interfaces. There can be other interfaces also. G0/0/1 like that. You search about that. Tomorrow you have to let me know. Correct? Okay. So you have configured this 3 IP on the router 2. And even online students, you also have to do the same. I want your full participation in the class, right? So now come to CLI. Okay, don't talk. If no, enable config space T. What is the host name we have?
R3.
Router 3. Interface G0/0. IP address is 192.168.23.2. 255, 255, 255.0. Give no shut. Give set. Done. Now interface. Interface loopback 1. IP address is 2.2.2.2. 255, 255, 255.0 and give exit. Then interface loopback 2. IP address is 22.22.22.22.255.255.255.0. Give exit. And tomorrow you all have to bring your laptops to show IP interface brief. Configure all the IP. Done. Now you come to router 1. You try to ping. Now, as you know that if we are in the enable mode, we will directly ping. If in the config mode, what we have to add? Do ping. Okay. So here you will write do ping 192.168.23. So as it is directly connected, it is pinging, right? Why it is 80%? Because lost in the ARP request packet for the first time. Next, when you will ping, it is going to be 100%. Now let us ping to other IP, that is 2.2.2. What do you think? It will ping? No. By different network, and that too also between two routers. So what is required here? Routing. Okay. So for doing this routing, we have two methods: static routing, dynamic routing. What do you mean by the term static routing? Configure manually. Automatically. See. So we have written here routing. Now we'll write the static routing. It is a routing process in which routes are manually added on the router. It is a routing process in which routes are manually added on the routers. It means where you have to know, means where you have to reach, that information will be given by whom? Network admin. Okay. Manually added on the routers by network admin. Right? One minute. Yes, so we were discussing about the static routing. So here we have written that it is a routing process in which routes are manually added on the routers by the network admins. Okay. It means what? It means that in this routing table, will not be changed automatically, right? It means routing table will not be changed automatically. So whenever there is a change in the network, so you can write one more point here. Whenever there is any change in the network, then that particular change has to be manually updated. Means let's say you have configured one route. Okay, that route is not working now. So is it router going to change its path automatically? No. It will be changing only when you are going to change the path. So what it requires, static routing, it requires manual configuration and manual interventions. Right? Now, as it requires manual configuration and manual intervention, so don't you think that it can be supported only for the smaller network? If you have very large network, how a network admin can perform all the changes all the time? Okay. So it is suitable for a smaller network. Okay. Now, if anything is not being changed automatically, it means everything is under the control of network admin. So it we can say that it provides more control in the network, correct? Because it is not going to change anything automatically, no? That's why. Now, one more thing. Here we can use any like basics router also. Because see, if anything has to be performed automatically, it means there more CPU utilization will be there. But here everything is going to be followed by whom? The admin only. So even if you take here basics router, it will work there. So we can say here less CPU utilization. These are all the properties of the static routing. It is a routing process in which routes are manually added on the routers by network admin. Routing table will not be changed automatically. Whenever there is a change in a network, that part of changes has to be manually updated. It requires manual configurations, manual interventions. It is suitable for a smaller network. It provides more control in the network, then less CPU utilizations. One more thing, in a static routing, as routes are manually added, it means network admin should have the information regarding destination network. Means he has to know no, where I have to send the traffic. He should be aware about the path. He should be aware about all the configuration. Then only he can do the configurations. Correct? But when you will come to the dynamic routing, in that scenario, network admin does not require to have the information of the destination network. Just he will be advertising what network? Directly connected network. That's all. Right? So in the static routing, metric cost is 0. Next, administrative distance value is 1. It means AD value of a static routing is what? 1. Now you will ask, what is AD value? Administrative distance value. See, all the routing protocol is going to have certain AD values. It determines, like, for example, if you are using any particular to reach a destination, see, in this only, let's say, from router 2 to reach this server, from this interface, let's consider this is 0/0 interface, okay? This interface, you are using here a static routing, okay? And with this interface, G0/1, you are using OSPF. And consider here that they both are the best path only, okay? This side you are doing the static, this side you are doing this OSPF. So AD value of static routing is 1 and AD value of OSPF is 110. So it says least AD value will be always preferred. It means if I have used static also, OSPF always, so it is also always going to prefer what? Static routing. Why? Because it is having the least ED value. That is called as a 1. Okay. So these are the properties of the static routing. And these are the all the functions where we can like all the methods that we can use for to perform the static routing. So it is based on 3 different methods, static routing. Like there are 3 different methods to configure this. One is directly connected. One is recursive, that is using next hop IP address. And one is fully specified static routing. Okay. Fully specified static routing is not supported in the Cisco packet tracer. That I will show you on the real devices. Metric cost is like, see, when you will come to the dynamic routing uses cost to calculate the best path. Cost are different criterias, different conditions. In this, it is not going to calculate best path automatically. That's why it does not uses any cost. Okay, because everything is being decided by whom? By the network. You can consider static routing like, if you like compare with the real examples. Let's say you want to travel from one place to another place. You are not taking decision how I have to travel. Who is deciding? Your parents are deciding. Then that is an example of static. It means that router has to send the packets. Router will not decide how to send packet. Who will decide? Network admin will decide. Okay, that's why it is in the control of network admin. Correct? But it is suitable only when we have less numbers of networks, small networks. It is not scalable. Means it cannot be supported in large network. Why? Because see, if you have very large network to configure every time, it is going to be very complex. If any changes, all the changes has to be manually updated. Not possible, right? So it is written. What is static routing? It says here that it is a straightforward method of routing that involves manual configuring. In this, routes are manually added to the routing table by network administrator, and each route specifies a destination network and the next hop addresses or the exit interface numbers. It means it is explaining you the different methods that can be used for doing this static routing. Okay. What are the methods for static routing? One is methods to configure static routing. One is what? Directly connected. Second is what? Using next hop IP address. Third is what? Fully specified static routing.
Sir, how do we, like you told, to find the best part number of hops is not enough.
Hmm.
So what are the things we consider?
We'll come to that part. We'll explain you all these different methods. That is based on the different routing protocols. Different protocol uses different metric cost to identify the best path. Okay, we'll come to that part. Just today we have started the routing. Tomorrow we'll discuss all these three different methods. We'll do all the configuration using directly connected. Next hop, fully specified. Okay. Then we'll start the default routing. After completing default routing and static routing, we'll start with dynamic. And in the dynamic, we'll start first with the routing information protocol. Okay. As RIP is not there in the syllabus of the CCNA, and it is not being used also, but we have to discuss, okay, how it works. What are the demerits we have? What are the... Okay. So we'll stop the recording.